Ved, what is an event?
Sir, the thing which is going to happen, or
Okay.
to which we are looking at that outcome.
Okay.
Sir, we can say event. It's defined as collection of an experiment.
Okay. Anyone else? What is event?
Sir, outcome of a random event. Sorry, a random experiment.
Okay. Outcome is an event.
Yes, sir.
Ritika, what is
Yes,
event?
sir.
What is event?
Sir, set of outcomes or
Uh,
collection of outcomes.
Okay. Harshit,
Yes, sir.
yes. What is event?
Sir, the um, things that happen for that outcome.
Mm, okay. Ajay,
Yes, sir.
yes. What is an event?
Event, uh, possible outcomes.
Okay.
I mean,
Okay. Okay. Fine. No problem. Searching for an exact answer. I mean, this Oroshiri.
Collect
Yes,
collection of outcomes.
is a collection of outcomes. Okay. Oroshiri.
Yes, sir.
Yes. Can you tell me what is event?
Event is basically the situation for which we are checking the outcomes that will come as a in the different ways or something.
Okay.
Sir,
Hmm.
sir, we can take the example of coin. Like when we flip a coin, there are two outcomes, heads and tails. So the events, you know,
Events.
um, that means we can take the example of coin. Whenever we flip the coin, there are going to be two outcomes of the experiment, heads and tails. So we can say that the events is related to this random experiment.
Okay. Sakshi and Manas are here. Yes. Any Sakshi?
So I just joined now. Can you repeat the question?
Yes. Yes. You don't need
Sir,
anything.
I just joined now. I don't know what is the
Yes.
question.
Yes. I know. That's why I'm asking both of you. Can you tell me what is an event? Any one of you, Manas or Sakshi. What is an event?
Sir, it is a particular process that happens.
Okay. Fine.
So, sir,
Huh.
Outcome, an
Uh,
outcome, or the collection of outcome of random experiments.
okay.
we could
Yes,
say, sir,
Aaron.
we
Yes,
could say
Aaron.
event is
Huh.
a set of outcomes which we get like A and B. So A belongs to E belongs E A and B belongs to E. So A and B will be two outcomes. So A and B belongs to set E.
Okay.
Sir, a subset of sample space.
Yes. An event is a subset of a sample space. Now let's go to what is sample space. Now you will recall what is a sample space.
So the
total number of outcomes that can happen.
Yes. So total number of outcomes is a sample space, and subset of a sample space is nothing but an event. Okay. So I'll just summarize whatever we have discussed. So what we started with this experiment, the terms that we saw just now. Experiment, then we saw sample space, then we saw event. And once we have got all of this, there was probability that we started with. Okay. So we will, what we will do is, we'll start with the experiment first of all. So when we are dealing with statistics, it is an experiment is not just associated with laboratory experiments. An experiment is virtually any operation that results in one or more outcomes. Okay. So say for an example, you may pass the exam or you will fail the exam. So there are two outcomes in this case. Okay, whenever you perform an operation and the results that you get, those are one or more outcomes that you will get. Such an operation is called an experiment. So I will just write this down. An experiment is virtually any operation that results in one or more outcomes. Okay, say for examples, for an example, what we have, appearing for exam, outcomes are is an experiment, with possibilities of, with outcomes, pass or fail. Tossing a coin, as Saurav said, tossing of coin, an experiment with outcomes, head or tail.
Sir,
Yes.
we can also give example of any sport. We can get two outcomes, either it is win or lose.
Yes, exactly. So rolling of a die, outcomes are
6.
1, 2, 3, 4, 5, 6. Okay. So experiments further are divided into two parts. What is a trial of an experiment? A trial of an experiment is nothing but performing the experiment once. Okay. So an experiment is performed once. So it is, what do we mean? We mean that the trial for the experiment is done once. Okay. In some cases, we do more than one trials. Okay. So in that type of cases, we'll see further what happens. Okay, so just for understanding, I'll just write it down: the trial of an experiment. Trial of an experiment. This means performing an experiment. So n trials means performing the experiment n times. Performing the experiment n times. So if a die is rolled 3 times, then the number of trials is
Three.
3. Okay. So depending on this experiment, so experiments are of 2 types. There are 2 types of experiment. So one is deterministic types of experiment. The first type is deterministic experiment. What do you think it could be? What does the word suggest?
The experiment.
One whose outcome may be predicted.
Yes. So the experiments in which the outcome can be predicted. Any example, particular example?
Tossing a coin.
No. Outcome cannot.
Combination of hydrogen oxygen. Like when we add them.
I'm not sure. Combination of hydrogen and oxygen, whether you will get H2O or.
Sir, heads or tails? While we flip a coin, we have a predicted outcome which will be either heads or either tails.
Okay, but still you are not, particular about the outcome, right?
सर बट दो ही आउटकम आएंगे ना, ऐसे
हाँ,
थोड़े
दो ही
बीच, तो
ही
it
आए.
will be either tails or heads.
Yes, but can you tell me exactly what you will get?
So we want only one outcome over here, or what?
Yes. So the experiments in which you will, you can determine the outcome, and this is going to be the outcome. H2O. Okay. No example.
Adding of two numbers, 2,
Yes.
3.
Yes.
3, 4, whatever.
So that always going to be, determine what is going to be the addition. No real life example. To throw a ball in the sky, what is the outcome? It is always going to fall down. So you just have one outcome there. So such type of experiments in which you just have one outcome, where the outcome is determined. Such experiments are called the deterministic experiment. An experiment for which The outcome is unique. The outcome is unique. Outcome can be predicted before the experiment is performed, before the trial. It's called deterministic experiment. These are not of so much importance because outcome we already know. We don't need to think too much about it. The real problem is okay. Let me just write it down. Write down the example. Example: throwing a ball in the sky. Outcome is will fall down. Falls down. Whereas in the other one, the more important one, which we actually need to study, is non-deterministic. So these are of particular importance where you don't have just one outcome, and then we need to think of the probability ki which outcome is more likely. Non-deterministic experiment.
Sir, I had a doubt.
Yes.
Sir, so the weather forecast, will it be a deterministic experiment? Like we predict it, it is going to be rainy or it is going to be hot weather. So will it come in the same thing?
It will be non-deterministic because it is a forecast. Okay.
Yes.
The experiment is what is going to be the weather. Okay. Most likely is it will rain, but it may happen that it didn't rain that day. Okay, so outcomes are the rainy or just the showers or heavy rain, or there is going to be no rain that day. Okay, so it is non-deterministic.
Sir,
Yes. Yes, Saurav. Go ahead.
means the uh, non-deterministic experiment, anything which can happen or where there is no a particular outcome will come in that type, right?
No, there are outcomes, but
Not only a single, but plenty.
Yes, more than one. An experiment with an experiment with more than one possible outcomes. More than one possible outcome. And the result of the experiment and the result of the experiment cannot be predicted. Okay, say for an example, rolling a die. So the outcomes are going to be 1, 2, 3, 4, 5, 6. Tossing of coin. blood group of a person.
Can we say selection of any project, because more than probably 2 or 3 projects can be selected like that?
Yes, blood group of a person. So that can be O, A, B, A, B, whatever. But can you, give an idea what his blood group is going to be if you know the blood group of their family members?
So, but sometimes it is different also, right?
Yes, sometimes it is different, but
We
can
can make the most probable.
yes. So the possibility plays a vital role. Okay, so if you know the blood group of the family members of a person, and you are predicting his blood group, then possibility is that if his father is of blood group A, mother is of blood group B, and if both are of A blood group, then the possibility of this person getting A blood group as A is more. Okay, and we can say that the 70% possibility that he'll get blood group A, and in 30% it may vary. Okay, so when you're performing non-deterministic experiments, the chance element plays a vital role in determining the outcome. Okay, so there are you can actually just say that there is a possibility that you will get this, but still the outcome is outcome can be different. Okay, so so this random modeling is done in this case. So we'll see what is random modeling in the further lectures. Right now, let's just focus on the definitions that we need for the studies. The next is the sample space. We have already seen what is a sample space. Set of all possible outcomes. All possible outcomes. Distinct in bracket. Of an experiment. Of an experiment is called sample space. Called sample space. Yes, anyone? How it is denoted by? Standard notation for this. You have done the program.
Capital S.
Capital S or
Phi, no, not phi.
Sigma.
Okay. Sir, and we also write a sample space in curly bracket, right?
Yes. So the sample space, I can say that it is nothing but the universal set. Okay. What do we mean by universal set? Universal set consists of all the possible outcomes which are related to that experiment. So if I'm rolling a die, then all the sample space is going to be 1, 2, 3, 4, 5, 6. So I'll just write the example down. Example. The first one, experiment is rolling a die. So the sample space for this is going to be 1, 2, 3, 4, 5, 6. Second example, tossing of coin twice.
HHHT.
Yeah,
THT.
both will be head HT, TH, and TT. Okay, so the elements of sample space, elements of sample space are called sample points. Okay, so this sample space are of two types. Before going to exact definition, I will ask you a simple question. In a particular class, if I measure height of each and every student, what will be the sample space? What could be the sample space? Okay, I'll give you a familiar one. Say if I measure the height of all the people in Maharashtra, then what could be the sample space?
So it will be height only.
Sample space. I want the sample space. It will be height, of course, but what will be the sample space? Yes.
Height of every person is 151, 152. Like
Yeah. Can it be simply 151?
No, sir. It will vary.
Sir, it could be from between 2 feet to 8 feet, or like 3 feet to 8 feet.
Yes, exactly. So the sample space is going to be an interval. That's
Yes,
what
sir.
you want to say, Aaron?
Yes, sir.
Sample space will be an interval. That's what you want to say?
Yes, sir. Yes, sir.
Yes.
Exactly.
Yes. So again, sample space are divided into two types. One is where you have particular outcomes, like we said that we are tossing a coin twice. So there are some 4 outcomes there: head, 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 tail, head, and tail. But when you are measuring height of a population, in that case, the outcome is an interval. Okay, so the sample space is divided into two types. One is the discrete sample space, and the other one is continuous random space, continuous sample space. So types of sample space. In the first one, discrete sample space. A sample space containing a finite number of points or countably infinite. I hope you are aware of this term, countably infinite. A sample space, containing finite or countably infinite. Sample points. Okay. Anyone knows what is countably infinite? Have you done this in the other course, discrete mathematics? Have you seen what is countably infinite?
So like anything which is countable, but it is too much that we are not able to count it.
Any example?
The rice grains in a bag. Number of rice grains.
Okay.
We can count them, but
you're
Set
actually
of integers.
Set of integers, a simple one. Of course, that is also right. The rice grains can be counted, but those are infinite. Okay, in a bag. So and the other one, finite. Finite is simply the number you can calculate. Say for an example, when you roll a die, there are just 6 outcomes. So this is the difference. So when you say finite, that can be counted. That are countably infinite. Those can also be counted, but the number is quite large. So countably infinite and finite sample space. So finite sample space. We won't go for the definitions of these, just the examples. These look like omega 1, omega 2, up to omega n. So there are n number of elements. Such sample space are finite sample space. So 2 coins are tossed, tossing of 2 coins, tossing of 2 coins. Second, card drawn from okay, so whatever is going to be the outcome, those are finite in this case. The other one is countably infinite sample space. Countably infinite sample space. So these look like, say, omega 1, omega 2, will go up to omega n and further dot. So it doesn't stop at omega n. but it goes up to infinity. There is no upper bound to this. So these are something that we can calculate, but I mean, these are something that we can count, but there is no upper bound to this. So examples of this. Yes, any example?
Set of
So the one we took before,
Set of
every people in Maharashtra one.
No. People in Maharashtra.
they are finite. Set of real number or integer.
No. We want an experiment in which you will get sample spaces countably infinite.
So numbers from 0 to infinity.
Again, tell me the experiment. What is going to be the experiment? Okay, say for an example, a student appears for an exam till he is going to pass. I mean, he can be of age, considering that exam doesn't have an age bar, what could be the sample space? So a student appears for an examination till he passes. What will be the sample space? Anyone? No idea?
Pass and fail.
Only pass and fail?
Or if it doesn't appear for exam.
No, that is not the possibility. He is going to appear.
Yes, then pass and fail only.
No. You're not understanding the experiment. The experiment is that.
So means he can attempt exam as many times he wants until he passes.
Yes, that is the experiment.
Number of attempts.
No, I want the sample space. Hasnan, please mute yourself.
Sir, means we need to tell the number.
No, you need to give the sample space.
Okay.
First time, second time, third time.
Yes, can you elaborate this? You are right, Ved, but you need to elaborate it. So he'll pass at the first attempt. So the possibility is pass, right?
Yes.
The first time he will fail, and the second time he will pass, right?
Yes.
Then he may fail 2 times, and then he will pass. He may fail 3 times, then he may pass. This can go up to ... whatever number of attempts he requires. Am I right? I hope this is clear. Is it clear?
Yes, sir.
Yes. Second is that the number of road accidents. Number of road accidents. On Mumbai Pune Express Highway. Expressway. The sample space is going to be 0, 1, 2, ... Okay, this can be counted, but there is no final count to this. The second type of sample space, continuous sample space. A sample space is continuous sample space if the number of elements in the sample space are uncountably infinite. So, if the number of outcomes are uncountably infinite, then the sample space is continuous sample space.
So numbers between two sub numbers, it maybe comes under that.
Just a minute. Yes.
Numbers between two sub numbers, suppose from 1 to 2, it may be infinite numbers.
Yes.
So it may comes under that.
Yes, it comes under continuous sample space.
Okay.
So the discrete definition also shows that.
No. There it is
Yeah.
countably infinite.
Yeah.
Now we are saying that uncountably infinite because if I tell you a simple task, say count the numbers between 0 and 1. So I have a closed interval 0, 1. Can you count the number between these two?
So they are infinite.
They are infinite, of course. Even integers are infinite, but what is the difference? Even integers are infinite, right? But what is the difference between the numbers in 0, 1, between 0, 1 and the integers? Say you will say 0.1. After 0, you will say 0.1, 0.2 and so on. You will go up to 1. Then I'll say that no, there is a number between 0 and 0.1, that is 0.01. It is between 0 and 1. Right? But if I say 0, 0.01, then there is a number between these two as well, which is 0.001. Are you getting my point?
Yes, sir.
Yes. So,
which means just between two numbers, again there are numbers which are
yes. So this is continuous. I mean, there is no break in it. But when you talk about the integers, there is a break between them, right? When we talk about integers, after 0, there is going to be 1. After 1, there is going to be 2. There is nothing between them when we are talking about integers. So I can count them. No matter till where it goes. It goes up to 1 lakh, 2 lakh, 3 lakh, 10 lakh, 1 million, 1 billion, billion crores, wherever it goes, I can still count that, right? But when we talk about the interval 0, 1, we cannot count because between every two, there will get something between them. Okay, so that's why it is continuous sample space. And this is called the uncountably infinite because I cannot count that and those are infinite. Example, first one? Height of population. Any other example? No other example.
Planets in the Milky Way.
Can you repeat it, Aaron?
Planets in the Milky Way.
Achha. But those are integer values, right?
Oh yes, sir. Sorry.
Yes. So that will be countably infinite.
Number of cars, can say.
No.
Okay.
Again, those can be counted.
The weight of population.
That is an example, but it is similar to height. Okay, anyways, I'll write it down, the weight of a population. But you think over it if you could get something.
So usage of fuel.
Yes, that could be an example. Usage of fuel. Let's write that. Fine. We'll just summarize everything that we have seen today. So we started with an experiment. For an experiment, we defined a sample space. Sample space, we saw that those are of two types. The one is discrete sample space. Discrete sample space. Another one is continuous sample space. Discrete sample space again can be of two types. One is finite sample space and the other one is countably infinite sample space. The continuous sample space is uncountably infinite. Okay, so what is remaining now from the list that we started with? So we need to define the events now. So I'll define the events in the next lecture, and of course it is a subset of a sample space, but again in the events part there are different types of events. There is a Venn diagram. We'll see how to draw the Venn diagrams for the same because Venn diagrams plays a major role in probability. Fine. That's all for today. If you have any difficulties, you can ask.